about to fall.
We good?
Yep.
Okay. So, don't adjust your setting. Okay, so x-axis, x equals 9, and the equation y equals x. So I kind of sketch it. You don't have to sketch it as nice. I sketch it just to kind of see what's going on. Oh, well this must be the area, right? Right there. It's gotta be that, in between all those three things. I'm gonna have isosceles right triangles as the cross section. So coming out of that weird shape are these isosceles right triangles. Of course, they won't be very big here. They'll only come out a little bit. But they're gonna come out really far when I get, this is gonna be the bigger over here. So that's what I'm building out from the base, these isosceles right triangles. The cross sections are perpendicular to the x-axis. That's one of the important things, because that means I'm going across the x-axis. So that's why I drew it like this. Okay, isosceles, and it said the right angle is along the x-axis. So an isosceles right triangle, the right triangle's on the x-axis. So that's it. And there's an isosceles right triangle. I mean, here it is right there. So this is what I'm trying to draw up here. These two sides are the same, right angle. Y'all kind of see the shape that's being formed out of that graph. And here's what we know about integrals. If I took the integral of this right here, that equation, I would get the area underneath it, right? Down to the x-axis. Okay. Well, if I take the area of the shapes coming out, I will get the volume. So if I took the integral of just this line, I get the area underneath it. If I take the area of the shapes coming out, I get the volume. So I know that. Volume will be the integral from whatever to whatever of the area. And in this case, in terms of x, because I'm going across the x-axis. Right? So I look over here, hey, what's the volume of this shape coming out? Well, I know this is the side that's in there in that base. And I know it's a triangle, so the area is going to be 1/2 base times height. That's the area of a triangle. I know the base is right there in that shape on the piece of paper. That base, it's going to go all the way up to y, which is the square root of x. So, yeah, the square root of x will be kind of big number here, not as big a number here. Hey, whatever x we're plugging in, that's the equation. It's going to go all the way up to the equation. That's going to be my base. Okay? So, I plug that into the area of a triangle. 1/2 base, square root of x, height. Well, it's isosceles, so the height's going to be the same as the base. This piece is going to be the same as that piece. So 1/2 square root of x, square root of x. Because it's isosceles. Which gives me 1/2 x. That's the area. So then I come over here. Volume is the integral from what to what of the area of dx. Well, the area I just figured out of what's coming out is an isosceles triangle. According to this, it's going to be 1/2 x dx because I'm going across the x-axis. From where to where? Well, starting at 0, and I'm going all the way, what they said was x equals 9. So from 0 to nothing. So just take the integral of that. We can pull the 1/2 out and do that. Once I get the integral, which is x squared over 4. Take that from 0 to 9. That'd be 9 squared over 4 minus the 0 squared over 4. Which would be 81 over 4 units cubed because it's volume. Question? We got to figure out the shape that's coming out from my graph. part of that shape is gonna be in that graph. That's the key to unlocking the shape. So that's why you kind of want to sketch enough for you to figure out, well, first of all, it's going across the x-axis here, and one of the isosceles sides is in that graph. So I'm going to use that side to figure out the area of that shape going across the x-axis. Again, however your shape, however your little sketch looks to help you. Okay, you're never gonna be graded on the sketch. So just whatever helps you. I'm trying to be neater and more accurate than you probably need to be. Because I'm trying to show you what's going on. You're just trying to communicate with yourself. Are we okay on that? I'll leave it up there on the board, but I want to go to the second one, which is actually number 4. We're going to go backwards. But I wanted to show you this one first. Once you try it a couple of times, you realize this one isn't so bad. The next one's got some things going on with it. They put whiteboard on the back of this. That's a waste of money. Okay, can I go to the other one? You sure? I won't erase it. Okay, so here's number 4. Here's number 4. Okay. I kind of drew it a little bit on number 4. An object, yeah, it looks really messy. I bet I'm not going to be able to pull it up to where it shows up exactly where I drew it. We'll try. Get the flip. Okay. Anyway. The cross sections are squares, and the area of a square. I know volume is the integral of the area. Why am I saying d1? Perpendicular to the y-axis. Ooh, I'm going this way. Perpendicular to the y-axis. So I'm going from here to here in terms of y. So I'm going to have dy. Y. But I know the area of a square. It's side times side, or side squared. So I'm going to have bigger squares here and not so big squares there. I got sides. I'm saying the side of this square is going to be a big square. It's bounded by the x-axis, the y-axis, the line x equals 1, and this graph, x cubed plus 1. So this right here. That piece right there is going to be the base of all these squares coming up. It's going to go down here because there's going to be little teeny squares. These are going to be the big squares. So again, I'm just trying to draw what it looks like. Okay, and I know volume is going to be the integral from A to B of the area side times side. I just need to figure out what's the side. Well, as I look at this, I notice something. That graph right here, x cubed plus 1, when x is 0, y is 1, so it's going to start right there. And when x is 1, where it ends, y is 2. Right there. Oh. So it looks like I could probably go ahead and say from 1 to 2. Well, I got this piece. This is 0, 1, 2. Don't need to put it on it twice. Hey, so I know it's gonna go from 0 to 2 in the y direction. Okay, but then I noticed something else. That shape, that graph doesn't go the whole distance from 0 to 2. That graph only starts at 1 and goes to 2. I really only need that graph in this part. And if I look down here, wait a minute, that's just a cube. That's going from 0 to 1, out to 1. It's a square, so it's going out 1. 1, 1, 1. That's just a cube right there. I know the volume of a cube. Length times width times height. 1 times 1 times 1. Oh, I can do that. 1 plus, oh, then the integral I want is really only 1 to 2. I'm gonna add this weird looking piece right here to this cube. Cube was easy to figure out. So I go over here, volume's gonna be the cube. Plus this other piece that's going from 1 to 2 in the y direction. And they're gonna be squares. So I just need the side and then I can square it. So the side, here's the side of the square. What is that side? Well, I said this one's going all the way out to 1. So it's going all the way out, well, it's not quite going all the way. It's going all the way out to 1, but I don't want the full 1. I only want this part. I don't need this part. Well, why don't I just subtract that away? So I'll have 1 minus the part I don't want. And that's what I'm doing over here. 1 minus the part I don't want will leave me this little wedge in here. That's what the side is. 1 minus this part, this dead zone that I don't even want. Well, what is that dead zone? Well, it's that equation. X cubed plus 1, right? Go out to 1, subtract this, just like we did for area, right? This is the part I don't want, and we're doing the integral of area. Will leave me this piece that I do want. 1 minus x cubed plus 1. 1 minus this square. Okay, there we go. Oh, the only problem is, I want to do it in terms of y. Because these squares are moving across the y-axis. Okay, well then all I have to do is rewrite this in terms of y, or in terms of, so I know this is, where did I do that? Maybe I did it. Okay. So we'll do that down. I don't want to mess that up anymore. We'll do that. So that is y equals x cubed plus 1. And that's that equation, so I'm going to subtract that away from going out to 1. Subtract it away, I'll be left with that whole piece right here. But because I'm doing it in terms of y, I need a y here. So I'm going to do y minus 1 equals x cubed. So x will be the cube root of y minus 1. That's the same equation, just in terms of y instead of x. So I'm going to take that and put it in here, and then I'm going in terms of y. And then I can just integrate that. And we just did it on the calculator. 1 plus, hey, it turned out that that's the side, by the way. That's the side. 1 minus that piece gives me that side. So side squared, don't forget it's side squared. side times side, which is why we're squaring it. Just put it in the calculator, that's what I'll leave that one on. But that one, you know, we weren't going across the x-axis, we were going across the y-axis. And I kind of had to notice it. So we were scratching our heads a little bit on those. Okay, so there's those two. Let's do another one. This time we'll do number 6. We'll try number 6. And then if we want to do another one. But we at least want to do number 6 because it's got a new shape. We've done triangles. We've done squares. We did rectangles. What we have not done yet are circles, or specifically in this case a semicircle. So here's the fun part. I get to draw. Okay. So let's see what we got. Find the volume of an object. The base is bounded by the x-axis, the y-axis, and it's kind of hard to see. The equation is y equals 4 minus the square root of 4 minus x. Square root of 4 minus x. Okay, so x-axis, y-axis. The cross sections are semicircles. The base of the semicircle is in the graph, perpendicular to the y-axis. So let me draw that. Okay. So we got that. X-axis, y-axis, here, here, and I've got that. I need to see where the base is. What's the base of the base? Let's see, when x is 0, I got 2, right? When x is 0, I got 2. When's it gonna equal, oh, at 4, right? When x is 4, y is 0. Yeah. So there's that. Y equals the square root of 4 minus x. And what's going on in there? I've got cross sections to the y-axis. Oh, I know I'm going to be doing this. I'm going to find the volume of A to B. Probably figure out what A to B if it's going across the y-axis. Of the area in terms of y dy. So here's what my cross sections are. I'll draw one up here. I don't know if that really looks like that's kind of a semicircle. And of course, as I move down, the semicircle is going to get bigger and bigger, right? It's really going to come out big. But these are coming out now. So they're sort of coming out. Hey, what's the area of the semicircle? Well, what's the area of a circle? Pi r squared. And semi is half a circle, right? So 1/2 pi r squared? 1/2 pi r squared. Okay. I just need to take the integral of that. 1/2 pi r squared. Well, 1/2 constant pi, constant r. Oh, that radius is going to be changing. I got the diameter in there. Well, let's take it a step at a time. I'm going all the way out to whatever that equation is. That's going to be the diameter. So, what did I say? Let's see. So this that's the diameter. And I'm going to have to put it in terms of y because I'm building these things across the y axis. So let me square both sides. Y squared equals 4 minus x. Let's see, I'll add the x over here. I'll subtract the y squared over here. X is 4 minus y squared. Well, that's the diameter. My area of a circle or a semicircle, specifically in this case, I need the radius, and then plug it into 1/2 pi r squared. Oh, well, the radius is just going to be 1/2 of that. Well, there we go. I think I got everything I can plug in for my area now. Let's see. That's the area, and to do the integral, well, find the volume. Wait for that. Volume will equal the integral of the radius. From where to where? Well, going across the y-axis from 0 to 2. From 0 to 2. I know I can put dy over. 1/2 pi radius 1/2 on the 4 minus y squared. R squared, radius squared. So there's my 1/2 pi r squared. And we can probably clean that up. That's going to be, let's see, that's going to be the integral from 0 to 2. Let's say I got 1/2 times pi, that's a constant too, and if I square what's inside, I get 1/2 pi 1/4, 4 minus y squared, squared. That's squared and that's squared. And then that is 1/8. And the pi is a constant. I can pull those out and then just worry about this part. 4 minus y squared squared. We could do that in the calculator. I could probably do it by hand. I'm going to say pi over 8 instead of 1. Pi over 8. Integral 0 to 2. That would be 16 minus 8y squared plus y to the 4th in terms of. So I probably could take the integral of those pieces. But you could probably do it in the calculator. It's the setup that's most important.
what you got.
Well, the good thing from 0 to 2, 0 is gonna give you 0. So I really just have to plug in the 2. What'd you get?
6.7.
That's what I got. If we had to do it by hand, minus 0, minus 0, plus 0, 0 just like that. Really, all you have to do is plug in the 2 and then multiply by 5. Whatever that comes out to. Roughly, what'd you say,
6.702.
Yeah.
2 units. So 2 things you gotta do with these problems is figure out the shape that's coming out at you. And then figure out if it's going against the x-axis or the y. And a lot of times, I mean, on those ones you were asking about, they were already written x equals, so I didn't have to change the equation. But a lot of times it's gonna be y equals, and you notice it's saying it's going across the y-axis. God, I forget to change the y. I'll just change the We can do one more if you want. We got 20. Should we do one more?
Yes.
We'll do another triangle. Any questions on this? Any questions? The next question I have, I just, if we needed another example, you could probably do everything without it, but I just figured, I'm gonna do another equation, I'm gonna make it, or another example, I'm gonna make it good. And this would be number
Yo,
seven.
what's your deal?
This is gonna be number 7.
It's after a break.
We're chopped.
Okay, so number 7.
It's my birthday gift. It's the day before my birthday.
Oh, there's one.
And then
What a gift.
Okay, I have a solid with a circular base with a radius of 1. With parallel cross sections perpendicular to the base being equilateral triangle. I didn't say it, did I? Did I say perpendicular to the x-axis? Number 7.
Perpendicular to the base.
Yeah, it won't really matter if you make it go across the y-axis or the x-axis, I'll show you, because it's an equilateral triangle and it's a circle. So it's gonna go as much in that direction as it's gonna go in that direction. It's gonna be, but we'll draw it. We don't have an equation. Put on here. Let's see, a solid with a circular base of radius 1. Circle with a radius of 1. I bet that equation could be x squared plus y squared equals 1. And I'm building equilateral triangles. So, and the base is in here, so let's see. Do you want to go across the x-axis? Okay, so if we're going across the x-axis, I'll do a little one here. Equilateral triangle. That means all on the sides are the same. It's not isosceles, all of them. And of course, I'd have a bigger one here, right? So probably just miss it. because I'm gonna show you, it doesn't really matter. What if I built this going across the y-axis? Wouldn't it be the same shape? I just like turn it 90 degrees. But the triangles would be the same base and everything, so it doesn't matter on this particular one which way I go. And so I probably want to figure out this. The equation y squared equals 1 minus x squared. Y is the square root of 1 minus x squared. And there it is in terms of x if we're going to go across the x-axis. So we're going across the x-axis. Now let's look at my triangle. Hey, that base of that triangle, which is an equilateral side, is going all the way to that function, right? It's going all the way up to square root of 1 minus x squared. So the side I bet it would be 2 of those. So that's going to be 2 of 1 minus x, square root of 1 minus x squared. That's going to be the same thing. That's going to be the same thing. They're all equilateral. So I need the area of that triangle. One F base, I'm sorry. Well, I think I have the base, 1/2 the base. It's going up and then I'll double it. 1/2, 2 square root of 1 minus x squared times the height. No, that is a horrible equilateral. Sorry. More equilateral. Yeah, it's going to be equilateral. Okay, so we know this is in here on the graph. 2 square root of 1. And that's what that is. But we want the height. Yours doesn't have to be perfect. That's the height. One of the sides is not the height. How can I figure out the height of that thing?
Divide the triangle.
Divide the triangle. Well then, that would only be this. It wouldn't be the whole thing, right? It'd only be one of those. Okay, how's that give me the height?
What do you say?
How do I get the height from?
Yeah, like you divide it and then you say that that side is square root of 1 minus x squared, and then the other one is 2.
Couple of ways you could do it. Yeah, if I do this, equilateral triangles are all 60 degrees. If I just cut that in half, that's 30 degrees. I could use a little trick. Also the Pythagorean theorem. So that's going to be this squared plus this squared equals that squared, or that squared. What was that squared? Oh, it was 2. 1 minus x squared. That side was 2, 1 minus x squared squared minus that squared. Equals the height squared. Or you can use, but I like trig better. What do you think that dimension is, the height? Let's say I got 4 of these minus 1 of those, that's 3 of those. That's the height squared, so the height would be the square root of 3 times the square root of 1 minus 6. Square root of, or the square root of. Take square root of both sides. Okay, let's come over here. That is gonna be, volume's gonna be the integral of the area. The area is 1/2 base times, we now have the height. 1/2 the base, 2 of those things. The height, we just figured out from Pythagorean theorem, or we could have used trig, is the square root of 3 times the square root, or the square of the whole thing, if you want to, 1 minus x squared. And dx, and it's already in terms of x, we didn't have to do anything there. And I gotta figure out, well, I'm going from what to what? I'm going in terms of x, so -1 to 1. -1 to 1. See if I can clean that up before I do this. Ooh. Never mind. We'll clean up the inside first. So 1/2 of 2 is just 1. So I got the square root of 3. And then I got the square root of this times the square root of that. Well, that's just this. Dx. And I could probably really simplify that. That could be integral square root of 3 minus square root of 3x squared. I could do that integral by hand. Dx. And you know what else? I'm gonna do it by hand. Why can't I just go from 0 to 1 and double it? Because I like me some zeros. Go to 0 to 1 and just double it. I'll get 2 sides of it. This side's gonna be the same as this side because it's a circle. If I'm gonna do it by hand, it's nice to plug in a 0. It's also nice to plug in a 1. But you don't have to. You can keep it negative. I did do it by hand. So let me show you everything I did. Actually, you know what I'm gonna do? I'm not gonna do that. I'm gonna keep this, because I'm gonna do this. I'm gonna pull that 2 root 3 out here, and then just take the integral from 0 to 1 of 1 minus x squared. That'll be even easier. Yeah, that'll be even easier. So that'll be 2 square root of 3. And then I'm gonna get x minus x cubed over 3. Take that from 0 to 1. And then I'm gonna multiply by that. That's that's gonna be pretty, because I'm plugging in 1 and 0. So that's gonna be 2 square root of 3, 1 minus 1/3, minus 0 minus 0 third. So that's 2 root 3. 1 minus 1/3. Isn't that just 2/3? And then minus 0. And that's gonna give me 2 root 3, 4 root 3 over. Hey, I did it. You'd get the same thing if you went from -1 to 1. You get the same. You would just have to plug in 1 and 1 and then -1, so you'd be adding the other piece back, which is exactly what we did by the 1 and 2.
You can put measurement.
Oh, yeah, and I'm not giving you the measure, so units cubed. Because it did say volume. Okay. Okay, the only thing I can do after this is say, guys, you gotta practice. We gotta practice. Now, here's what I'm gonna do to give you some time. I do wanna show you something else tomorrow. But I was gonna throw something in our study that you did not need. And you didn't need this for AP calculus. I'm gonna take it back out. I'm not gonna give you something. It won't be on, but, yeah, so this Thursday and Friday, I was gonna give you part of it here. And you don't need to do that. So we'll just continue with what you need. And so we have those 2 days, Thursday and Friday, because we missed the 2 days last week. And since you don't need this stuff, I mean, it does kind of help. But College Board says they don't need to know it. Okay. Well, if we don't need to know it, that'll last 2 days.